Dear students, in previous class we discussed about the convergence property of some sequences. So, if x equals xn be a sequence which is converges to x and sequence yn converges to y, then sequence xn yn, consider their product, sequence xn yn converges to xy. So this is how to prove this one. We already proved that when xn converges to x and yn converges to y, then xn plus yn converges to x plus y, as well as yn plus converges to xn plus yn converges to x plus y, and xn minus yn converges to x minus y. Now to prove when xn and yn are two sequences converges to x and y respectively, we prove xn yn converges to xy. Xn converges to x means modulo for all n greater than or equals k1 for n modulus of xn minus x strictly less than some epsilon by 2. And again yn converges to y means for all n greater than or equals k2 for n such that modulus of yn minus y strictly less than epsilon by 2. Put k equals maximum of this k1 and k2, maximum k1 k2, then these two results are hold for all n greater than or equals k. Now consider modulus of xn yn minus xy. Modulus of xn yn minus xy equals modulus of xn yn minus xyn plus xyn minus xy. You can introduce minus xyn and plus xyn simultaneously. So what I get? By triangle inequality, it is less than or equals modulus of xn yn minus xyn plus modulus of xyn minus xy. Agree. So it is less than or equals here modulus of xn minus x into mod yn plus modulus of x into modulus of yn minus y. But what is sequence xn and yn? They are bounded sequences. Sequence xn and sequence yn are the sequence of real numbers. Always they are bounded. Hence, it is less than or equals convergent sequence are bounded. Since sequence xn and sequence yn are the convergent sequence, hence they are bounded. Therefore, it is less than or equals some m into modulus of or m1 into modulus of xn minus x plus m2 into modulus of yn minus y. Agreed. Put m equals maximum of m equals maximum of this m1 and m2. So what do you get? These two, so means modulus of xn yn minus xy, modulus of xn yn minus xy less than or equals m into modulus of xn minus x plus modulus of yn minus y. Agreed? Yes. So suppose it is less than or equals epsilon by, instead of epsilon by 2, you can choose epsilon by m here. So it is strictly less than m into epsilon by m equals some epsilon. Therefore, sequence xn yn converges to xy. Agreed. So when sequence xn and yn are any two sequence of real numbers converges to x and y respectively, then xn yn converges to xy. Now, when xn is a sequence of real numbers, it is converges to xn. Then cxn converges to cxn converges to cx. Cxn converges to cxn converges to cx. How? We choose sequence yn. Sequence yn equals sequence c, etc. That's a constant sequence. Then clearly sequence yn converges to c. Agreed. When xn converges to x and yn converges to y, then we already proved that x and yn converges to xy. Therefore, c into xn converges to cx. Okay, instead of yn, here it is c, here it is c. So when xn converges to x, and then Cxn converges to Cx. Agreed? Now, by using these properties, we prove some and other results. The first one is, given Zn differs from 0. Given Zn differs from 0 for all n and the Z differs from 0, then the quotient sequence xn by z, or let x equals sequence xn, which converges to xn, then the quotient sequence z equals and the z equals sequence zn, then the quotient sequence x by z converges to x by z. Means sequence xn by zn converges to, that means sequence xn by zn converges to x by z. Sequence xn by zn converges to x by z. How to prove this one? So for, consider modulus of 1 by zn minus 1 by z. 1 by zn minus 1 by z. What is 1 by zn minus 1 by z? That is z minus modulus of z minus zn divided by mod z into mod z. Agreed? Mod z minus zn by mod z into mod z. Now, but what is sequence zn? Given that z equals sequence zn converges to z. Converges to z. That means for all epsilon positive, agreed? For all epsilon positive, there exists some k1 following n such that modulus of zn minus z strictly less than epsilon. So for more convenience, since z differs from 0, as well as z is a sequence of non-negative reals, there is a hypothesis, z is a sequence of non-negative reals, then put epsilon equals z by 2. Put epsilon equals z by 2. Z by 2 is positive. Therefore, this is strictly less than modulus of z by 2, or strictly less than z by 2. Agree? So epsilon equals mod z by 2. Put epsilon equals mod z by 2. Then mod zn minus z strictly less than mod z by 2 for all n greater than or equals k. Okay, but what about modulus of mod zn minus mod zn? Mod zn minus mod z less than or equals modulus of zn minus z. Agreed? Okay. Which is strictly less than modulus of z by 2 by using this argument. That means mod zn minus mod z strictly less than or mod z minus mod z. For more convenience, you can consider mod z minus z, modulus of z minus or mod z minus mod zn less than or equals modulus of z minus zn, but modulus of z minus zn strictly less than mod z by 2. So that means mod z minus mod zn strictly less than mod z by 2. So what I get? That means mod z by 2 strictly less than mod z. Mod z by 2 strictly less than mod z for all n greater than or equals k1. Agreed? Okay. Now, if epsilon is positive, since sequence zn converges to z, again, that means there exists some k2 following n such that that's a natural number k2 such that modulus of zn minus z strictly less than epsilon into mod z square by 2. Agreed? Since mod z is positive, mod z square by 2 is positive, epsilon is positive, so it is mod zn minus 2 less than epsilon into mod z square by 2 for all n greater than or equals k2. Put a k equals maximum of this k1 and k2. K equals maximum of this k1 and k2. Then the above results are false for all n greater than or equals k. Agree? Then, so again from 1, consider this modulus of 1 by Zn minus 1 by Z. From 1, so 1 gives 1 by modulus of 1 by Zn minus 1 by Z equals mod Z minus Zn. But what is mod Z minus Zn? That is strictly less than epsilon into mod Z square by 2 divided by mod Z into mod Z. Mod Z into mod Z means by mod Z into, what about mod Z? Here, mod Z by 2 strictly less than mod Z. So 1 by mod Z, it is less than 2 by mod Z. Enough. So equals some epsilon. That means 1 by mod Z, modulus of 1 by Zn minus 1 by Z strictly less than epsilon. That means 1 by Zn secants 1 by Zn converges to 1 by Z since epsilon being arbitrary. Also we know that what is xn? Secants xn converges to x and 1 by Zn converges to 1 by Z. Then by the previous argument you have xn by xn into 1 by Zn converges to x into 1 by Z. That is secant xn by Zn converges to x by Z. So when secants xn and Zn be the sequence of real numbers, xn converges to x and Zn converges to Z, then xn by Zn converges to x by Z. Agreed. So this is the other result for the convergence of a sequence. Agreed. Now come to another result. If x equals sequence xn is a convergent sequence of real numbers, x equals sequence xn be a convergent sequence of real numbers, and xn greater than or equals 0, xn greater than or equals 0 for all n falling n, for all n falling n, then limit xn greater than or equals 0. If xn greater than or equals 0, then limit of xn greater than or equals 0 for all n fallen n. How? So the proof is, suppose secant xn converges to x itself. Secant xn converges to x. Assume x is negative. If possible, x is negative. X negative means what is minus x? Minus x should be positive. When xn converges to x, assume if possible x is negative, then minus x should be positive. Xn converges to x means for all epsilon positive, there exists a k fallen n such that modulus of xn minus x strictly less than epsilon for all n greater than or equals k. Agree? That means minus epsilon less than xn minus x strictly less than epsilon for all n greater than or equals k. That means x minus epsilon less than xn less than x plus epsilon for all n greater than or equals k. Since epsilon is positive and minus x is greater than 0, so you can choose epsilon is minus x. So the above argument gives x minus minus x less than epsilon, xn less than x minus x, x plus minus x. That means 2x strictly less than xn strictly less than 0. 2x less than xn less than 0 for all n greater than k, greater than or equals k. That means secant xn is less than 0 for all n greater than or equals k, a contradiction to the choice of this xn where xn greater than or equals 0. This contradiction is due to our wrong assumption, therefore x greater than or equals 0. What is actually x? X is limit of xn, that means limit xn greater than or equals 0. This is what we deduce. Enough. So when xn greater than or equals 0, then xn be a sequence of non-negative reals then it converges to a non-negative real number. Xn greater than or equals 0, then limit xn also greater than or equals 0. Agree? Okay. Now, consider another result. If sequence x equals xn, if x equals xn and y equals y, if x equals xn and y equals yn are any two sequence of real numbers with xn less than or equals y, xn less than or equals y, then prove that limit xn less than or equals limit y. Xn less than or equals yn, then prove that limit xn less than or equals limit yn for all n following n. How? So it is given xn and yn are any two sequence, xn and sequence yn are any two sequence of real numbers. So with xn less than or equals yn for all n following n. Xn less than or equals yn means yn minus xn greater than or equals 0 for all n following n. Put Zn equals yn minus xn. So clearly this Zn greater than or equals 0 for all n following n. Agreed? That means Zn greater than or equals 0 by the previous argument. In previous theorem, we also know that when xn greater than or equals 0, limit xn greater than or equals 0. Here Zn greater than or equals 0 should implies limit Zn greater than or equals 0 for all n following n. What is limit Zn? That means the limit of yn minus xn greater than or equals 0 for all n following n. That means limit yn greater than or equals limit xn means limit xn less than or equals limit yn for all n following n. This is the requirement. So when xn and yn are sequence of reals with xn less than equals yn, then limit xn less than or equals limit y. Enough. So again, suppose sequence xn and sequence xn be a convergent sequence of real numbers. That is x equals secant xn be a convergent sequence of real numbers with a less than or equals xn less than or equals b. A less than or equals xn less than or equals b, where n following n. Then a less than or equals, then a less than or equals limit xn less than or equals b. If a less than or equals xn less than or equals b, then a less than or equals limit xn less than or equals b. How? First you consider xn less than or equals b. Xn less than or equals b. Put yn equals b. Put yn equals b means yn is a constant sequence. Yn equals b means what is sequence yn? B, b, etc. Agreed? So it is a constant sequence. That's a constant sequence. Hence put yn equals b. So what do you get? We have xn less than or equals y. By the previous argument, when xn less than or equals yn, what about a limit xn? Limit xn less than or equals limit y. Okay, that means limit xn less than or equals limit what is yn? Yn equals b, limit b equals b. Means limit xn less than or equals b. Okay, again let Zn equals a. Means Zn is a constant sequence. Then from here we have it is a less than or equals xn. That means Zn less than or equals xn. By taking limit on both sides and by using the above theorem, this limit Zn less than or equals limit xn. Limit Zn means again a, so it is a less than or equals limit xn. combines, we have a less than or equals limit xn less than or equals b. So when xn less than or equals, when xn less than a less than or equals xn less than or equals b, then a less than or equals limit xn less than or equals b for all n for n itself. Agreed. Now, using these properties, using the above properties of the limit, we prove another theorem. It is known as Skews theorem. Skews theorem states that when sequence xn and sequence yn are unit and sequence zn are any three sequence of real numbers with the xn less than or equals yn less than or equals zn for all n for n, and let limit xn equals limit zn, y equals yn converges, then limit xn equals limit yn equals limit zn. If xn less than or equals yn less than or equals n, then if there exists a case limit xn equals limit zn, then limit xn equals limit yn equals limit zn. That is, the theorem is said to be, that's a Skews. The theorem is known as Skews theorem.